Okay, in this section of the class we're going to learn how to solve equations of the form x squared equals c, and you'll see what I mean by that as I write it on the board. Equations of the form x squared equals c. We haven't actually solved too many equations of this type before, so we're going to go ahead and solve that now. Let me give you an example of what I'm talking about. If we have, for instance, an equation that looks like x squared minus 9 equals 0, how would I solve that? Well, I could move the 9 over here, and in fact that's exactly what I'm going to do first. X squared equal, I'm going to move the 9 over by adding 9 to both sides, so I'm going to do that. 9 over here, if you add it to this side, 0 plus 9 gives me 9, so that's why I've got that. And then of course I've already told you in a previous lecture, the opposite of a square is a square root. Okay, so what I'm going to do is I'm going to take the square root of both sides. If I were to, do a square root here, you would see that it would just cancel with the square, so I'm left with x. Opposite of a square is a square root, equals, I've got to do it to the right-hand side, so square root of 9. So then that means x is equal to 3. But don't forget that it's not just 3, it's plus or minus 3. Let me write that a little bit bigger so you can see that. X will equal plus or minus 3. Anytime in math, when you're solving an equation that's like x squared equals something, remember our general form is x squared equals c, when you solve for x by taking a square root to get rid of this square and put it over here, you go ahead and take the square root just like you usually do, but you have to put a plus minus in front of it. What this means is x can equal 3 and x can equal minus 3. There's two solutions to this equation. Both of them are valid. Let's figure out why. If we take 3 and put it in here, we've got 3 squared, which is 9. 9 minus 9 is 0, so that checks. If we take minus 3, negative 3, put it in here. Negative 3 squared, again, negative 3 times negative 3 is positive 9. Negative times negative gives me a positive. 9 minus 9 is 0, so this solution checks. One thing you'll notice is in equations, when you have this is called a polynomial really, when you have x raised to some power, the highest exponent in your equation, in this case it's squared, is going to dictate the number of solutions that you're going to have. Here you've got a 2, that's the highest power, so you're going to have 2 solutions. If you had an equation, we're not going to learn how to do it in this section, but if you had an equation with a x cubed, you have 3 solutions. And all 3 of them, or all 2 of them in this case, will work. And you can see that because when you plug them in back into the top, they in fact do work. So let's try something a little bit different. What if we had 3x squared plus 9x equals 0? Notice again this equation has a x squared term, that's the highest order of the highest exponent here, so we're going to have 2 solutions we can expect. How do we do this? I could move the 9 over and all that, but really I want to get x by itself, and moving the 9x over isn't going to do anything. What I need to do is factor here. What's common between this term and this term? I've got a 3 here, and I've got, well, it's 9, but I've got a 3 kind of wrapped up in here. So I'm going to factor a 3 out, and then here I've got an x squared and an x. X is common to both of those, so I can pull an x out. And then I need to make some parentheses and figure out what goes in the middle. What goes here is just simply x, because 3x times x gives me x squared. And then over here, all I need is a 3, because 3 times 3x gives me 9x. So you need to check yourself by distributing and make sure that it equals the top. So you might say, this doesn't look any simpler. How can I use this? Well, one thing to realize is, in order for this whole thing to be 0, either this quantity can be 0, which will drive the whole thing to 0, or this quantity can be 0, which will drive the whole thing to 0. Because if this is 0, well, 0 times anything is 0, and vice versa. So what we do is we write 2 little mini equations down. 3x is 0, or x plus 3 equals 0. So this is equal to 0, or this is equal to 0. Either one of these can make the whole thing equal to 0. To solve for x here, I just divide by 3, just like I always do. Of course, x is going to be 0 because 0 divided by 3 just gives me 0. And then over here, x is going to equal to negative 3 because I'm going to move this 3 over by subtracting it. 0 minus 3 gives me negative 3. So here are my two solutions. Again, we expected two solutions. If you were to take these individually and put them in, you'll find that each one of them obeys the equation. Let's move on up here in complexity. If we have x squared minus 5x plus 6 equals 0, okay? And we're going to say that that's x minus 2, x minus 3 equals 0. Okay? That may not seem so obvious to you, but the way I do that is, in fact, let me kind of start over with it to kind of slow down a little bit. I want to factor this into two sets of parentheses. You might remember this from earlier algebra. I put an x here and an x here because in the end, what I'm going to use is FOIL. First term times the first term, I'll just write it over here. First term times first term gives me x times x gives me x squared, so that checks out. Last term times the last term, these two terms here, need to equal 6. So I'm going to use 2 times 3. That's going to give me 6. So all of the letters and numbers are filled in. I just need to figure out what signs to put here. Okay? And I need, and you'll see why in a second, I need a negative sign here and a negative sign here to make this thing work out. Now, x times x gives me x squared. The last term, negative 2 times negative 3 gives me positive 6. Negative times negative gives me positive, so that checks. For the middle terms, for the inside term, I'm going to have negative 2x. Negative 2 times negative x gives me negative 2x. For the outside terms, I'm going to have negative 3 times x gives me negative 3x. Negative 2x minus 3x gives me negative 5x. So really this sign and this sign are going to kind of drive the signs, and you just need to play with the signs. If we had a plus here, well that wouldn't work at all because I'd have a positive 2x, 2 times x, positive 2x, negative 3x, and that's not going to add up to this. So that's incorrect. You need to have this. And then it becomes the same old thing. When you have parentheses times parentheses equals 0, each term individually, if you put it equal to 0, can give you 0 in the end. So you have x minus 2 equals 0, x minus 3 equals 0. So you write two little mini equations here. Solve for x. X is equal to 2. Move the 2 over by adding it. X is equal to 3. Move the 3 over by adding it. And you are good to go. You have two solutions for an equation with the highest power, which is a square, and that's what you expect, two solutions. Okay, we'll get into a little bit more complexity. 6x squared plus 11x plus 3 equals 0. Same thing, I've got x squared term, an x term, and a constant term. I need to factor this. So I need to put some parentheses and say that that's equal to 0. And my goal, really the hardest part of this problem, is figuring out how to factor it. I need to find the first two terms that will give me 6x squared. So I'm going to use 2x here and 3x here. 2x times 3x gives me 6x squared. So that works out. Next, I need to find the last terms. This times this needs to give me 3. The only two things that can be multiplied together to give you 3 are 1 times 3 gives me 3. Okay? And then I need to find out what signs go in here. So if I put a plus here and a plus here, let me see what I end up with. For the inside term, I've got 3x times 1. For the outside term, I've got 2x times 3 gives me 6x. Okay? So obviously, if I add these two together, that's going to be 9x. And that does not equal that. So that's wrong. Okay? And this is the kind of trial and error that you have to come to grips with, because when you're factoring, that's what you need to realize. So what can I do differently? I'm going to stick with the 2x and the 3x here, but I'm going to flip this around. I'm going to put the 3 here and the 1 here. 3 times 1 still gives me 3, so that's fine. Now let's see what we have. 3 times 3x is 9x for the inside term. 2x times 1 is 2x here. That's 11x. That's what I'm looking for. So this is the correct factor here. Again, I've got term times term equals 0. So the way I do that is I write two little mini equations. This term can equal 0, or this term can equal 0. Okay? To solve this one, I move the 3 over here. I'm going to get minus 3 because I subtract 3 from both sides. X is just going to equal negative 3 divided by 2 because I'm going to divide both sides by 2. Okay? And then for here, 3x is going to be equal to negative 1 because I moved this 1 over by subtracting. And x is going to equal negative 1/3 because I'm going to divide both sides by 3. So again, the only difference here is I've got some fractions that are the answer, but really I've got two solutions. I've got an equation with a square term in the highest order of the exponent, so I expect two solutions. If I were to plug each one of these individually in here and do the math, you'll find out that it will satisfy the equation. So really when you have equations of this type, what you need to do is factor and set the individual terms equal to 0. Okay, what if you had x squared plus 4x plus 4 equals 4? Okay. Well, the first thing I want to do is I want to kind of put this in standard form, and I want to get this 4. I want something to equal 0. So I want to kind of get this kind of over here. So I'm going to subtract 4 from both sides, and I'm going to be left with this right here, because when I subtract 4 from both sides, 4 minus 4 is 0, 4 minus 4 is 0, so they both drop from each side. From here, I notice I have an x here in terms of x squared and an x here, so I'm going to factor out an x, and the inside I'm going to be left with x plus 4, because x times x gives me x squared, x times 4 gives me 4x. So when you do this, you need to think, what goes here that will give me this, and what goes here that will give me this. Okay? So in the end, this term, I write two little mini equations. X equals 0, that's the first one. The second one is x plus 4 equals 0. And I just move the 4 over, so I subtract 4. And so I've got that. The first answer is 0. The second answer is minus 4. I've got two solutions. I've got an equation with a square term, so I expect two solutions. And that's that. What if we have 9x squared minus 12x plus 4 equals 16? Okay? Let's don't move the 16 over right away. Okay, let's do it a little bit differently. Let's factor the left-hand side. So first thing I do is I put my 2 set of parentheses and I say it's equal to 16. I need to figure out what goes in the first area here. And I want it, when I multiply them, I want it to be equal to this term. So I'm going to pick 3x for now and 3x for now, knowing full well that I may change that later. But 3x times 3x gives me 9x squared, so I start there. For 4, the last two terms are going to be multiplied to give me the 4. So I'm going to pick, for now, 2 times 2 is going to give me 4. And so I'm going to leave that. And now my goal is to pick some signs here that are going to make the middle term work out. So for right now, I'm going to pick negative signs. Negative 2 times negative 2 gives me positive 4. That checks. 3x times 3x gives me 9x squared. That checks. In the center, 2 times 3 is 6, but it's negative 2, so it's really negative 6x. For the outside terms, negative 2 times 3x, again, gives me negative 6x. When I add these two together, I get my negative 12x. So my choices worked out just fine. Okay? Now, if I notice, this term is exactly the same as this term. Okay? So I can write that as 3x minus 2 squared equals 16. Because really, this times this is the definition of what a square is, so I can just simplify that there. Now, remember earlier, how do you get rid of a square? because remember, I'm trying to solve for x. How do you get rid of a square? You take a square root. 3x minus 2 squared equals, I've got to apply the square root to both sides. Okay, this square root cancels with this 2, so I've got 3x minus 2. On the right-hand side, remember what I told you. Anytime you have a radical applied to something, and it's not just canceling and it has it there, you need to put plus minus and take the square root. Square root of 16 is 4. The reason you put the plus minus is that positive 4 times positive 4 gives you 16. Negative 4 times negative 4 also gives you 16, because negative times negative is positive. So when you do this, there's two numbers that satisfy this, so you have to write them both down. So really, this leads to two equations. The first one is 3x minus 2 equals 4. The second one is 3x minus 2 equals negative 4, because the right-hand side, there's two different numbers that will work out. Okay? For this one, 3x equals, and I move the 2 over by adding 2, so that's 6. 4 plus 2 is 6. X is going to be 6 divided by 3, which is just going to be equal to 2. Okay? And then over here, 3x, I move the 2 over, negative 4 plus 2 equals negative 2. Negative 4 plus 2 gives me negative 2. X is equal to negative 2 thirds, because I just divide both sides by 3 to get my x by itself. So here's one solution, and here's the other solution. Again, I have two solutions for an equation with a square term. That's what I expect. Really, I didn't do anything different. I factored, and I noticed that this was a square, so I wrote it like that. I did a square root to get rid of that square. Did it to both sides. When I applied it here, I had to put plus minus around the number, because anytime you do a square root, two numbers satisfy that square root. That led to two equations, which is what I expect, and two answers, which is what I also expect. Final problem is going to look like this. 6 times x squared minus 1 equals 4 times x squared plus 3. Okay. First thing I'm going to do here is just distribute these things in, and I think that'll make things easier. 6 times x squared, 6x squared. 6 times negative 1, negative 6. So I've distributed the 6 in. On the right-hand side, 4 times x squared is 4x squared. 4 times 3 is 12. Now I need to move this 4x squared over here, and I need to move this 6 over here, and then I'll be able to solve things. So to move the 4x squared over here, I'm going to subtract 4x. 6x squared minus 4x squared is 2x squared. 6x squared minus 4x squared, 2x squared, equals. I'm going to move the 6 over here, so I'm going to add 6. 12 plus 6 is 18, so I'm going to have 18 here. I'm going to move the 6 over there, so now I'm left with this. I'm going to get rid of this 2 by dividing both sides by 2. X squared equals 9. In order to get rid of this square, what do? I do the opposite, which is a square root. So when I do that, I get x, because the square cancels with the square root, equals square root of 9. And remember, anytime you apply a square root to a number, you've got to have two answers, plus minus 3. Because 3 times 3 gives you 9, and negative 3 times negative 3 also gives you 9.